Okay, and for our last example, we have got this time 3 different graphs. So I am first going to graph y equals 8, which is just a horizontal line crossing the y-axis at 8. So that's going to be right up here. Okay. And again, I'm going to call this one y1. Okay. Then x equals 0. This is going to be a vertical line crossing the x-axis at 0. Let me get a different color here. And then lastly, I'm going to graph y equals x cubed. I'm going to call that y2. And again, I'm going to just plug in, that is a 2 right there. It looks a little more like a 1. I'm going to go ahead and plug in everything from -2 to +2 on this one. So if I start with -2, -2 cubed is going to be -8. Then if I plug in -1, -1 cubed is going to be -1. If I plug in 0, 0 cubed is 0. If I plug in 1, 1 cubed will be 1. And then if I plug in 2, 2 cubed is going to be 8. And then I'm going to go ahead and draw my cubic function through those 5 points. And this is y2. And then the shaded area is just going to be the part that's included between the vertical line, the horizontal line, and the cubic function, which will be this little part right here. So here is where they intersect. So that's going to be my A. So my A will be 0 on this one. And then here is the second place. So B, and that x value right there is 2. Okay, so I'm just looking at these 2 intersection points, and you can look at the one on top up here as well. You're just looking at the left of the shaded area and the right at the shaded area, but at both of these places, this x value is 0. And then here, our x value is 2. So now I can go ahead and set up my integral. Okay. So A is 0, B is 2. Then I have to look at what's on top of the shaded area, which is the horizontal line. So that's my y1. That's going to be y1, which is 8, okay, minus, so we're not using this x equals 0. The equations are always going to be the y equals equation, not the x equals. That'll be on the left side of this equation, so it's not the top or the bottom. So you'll never put the x equals into your like y1 minus y2 or vice versa. And so then I'm going to look at the bottom of this, which is the x cubed. So this is going to be 8 minus x cubed dx. Okay. Now I can go ahead and do the antiderivative. So 8 is just going to turn into 8x minus, this is going to be 1/4 x to the 4th. So always, anytime you're doing the antiderivative, you're always adding 1 to the exponent and then dividing by that new exponent. And then I'm going to plug in 3, I'm going to plug in 0, and get my answer. Sorry, I'm not going to plug in 3, I'm going to plug in 2. So I'm going to plug in 2 first. So 8 times 2, 16, minus 1/4 times 2 to the 4th, which is also 16. Okay. Then if I plug in 0, 8 times 0 is just going to be 0. This will be 1/4 times 0. So I'm just going to get 0 when I plug in 0. So this is going to be 16 minus 1/4 times 16, which is 4. So that'll be 12 units squared for the area between those three curves. And now that we've gone through a few examples of area, we've posted a little area between curves review worksheet. It's just a handful of problems. So you'll want to go ahead and work through that just to make sure you remember how to do area between curves.